Hi, after all our discussion about domain and range and all the fancy ways to write domain and range for continuous functions, or continuous graphs, I should say, we're now going to look at what is a function, all right? So, before we were talking about relations, and a function is a special relation. All right, so, a function is a relation in which each member of the domain is paired with exactly one member of the range. So if, let's say some of these ordered pairs, let's say if I had 1, 2, 1, not 1, 4, 7, 3, 8, this would be a function. Okay, I don't have to be able to write a special rule. If all of the x's are different, it will be a function. This would not be a function. So there's my function I had before. If I have another point and it has the same x as one of these other points, it's not a function. Now, kind of a bit of a double standard, I guess you might think of it, but had this also had, that's still a function. The y's can be the same, that's okay. It is not okay for the x's to repeat. So we're going to look here at these examples and determine if they are functions or they are not functions. So I'll do a couple in each section here. So again, if all of the x's are different, it's a function. If I'm looking at ordered pairs, I don't even really need to even look at the y's. So when I look at this one in number 1, 5, 3, 2, 0, -1. They are all different. This is a function. When I look here, -2, 0, 2, 3, 2. Aha. These two, x's being the same, is not a function. Okay, notice I did not, it wasn't just I didn't talk about it, I was not looking at the y's at all. I was only looking at the x's. Because every member of the domain, every x can only be paired with one y. So when 2 shows up with -4 and then shows up again with 4, it's being paired with more than one y. So it's not a function. Same thing with the tables. I'm just going to glance down the x column. If everything in the x column is different, all those are different, yes. I'm looking down the x column. I see something that's the same, no. It does not matter even if all of the y's are the same. All of these x's are different. This is still yes. So kind of, you might think of it as a double standard. The y can repeat, but the x cannot to be a function. So what does that look like when we're talking about our mapping diagrams? Well, for our mapping diagrams, that means we only want one line coming away from each x. So a number 11 here, yes, that is a function. So we have -3, 0, -1, 4, 2, 7, and 4, 4. But they would all have different x's. Number 12 is a no. And is a no because of -1. Because we have -1 paired with -1, and -1 is paired with 7. And then this one, again, a yes. It's okay. This is okay. It's when they have 2 coming from the same place, from the same x, that it's going to be a no. So if we, that would help that helps us from a table, from ordered pairs, and the mapping diagram to decide. But if we have a graph, we can use the vertical line test. Okay, so vertical line meaning a straight up and down line. So this way is vertical. So vertical line test. Given the graph of a relation, the vertical line test can be used to determine whether the relation is a function. The vertical line test states that for a function, no vertical line intersects the graph in more than one place. So if there is a vertical line that crosses in more than one place, in other words, that have points on top of one another, then it would not be a function. More than, one place belongs in there, one. So some things that are a function. So here's my coordinate plane. That line, that's a function. Doesn't have to be a straight line though. I could have a parabola. That's a function. I could have absolute value function. Looks like a V. Also a function. Those are all functions. If I drew any vertical line and like moved across, it only touches the graph in one place at a time. Some examples that are not a function. Alright, so not a function, if I took that parabola and put it on its side, that would not be a function because this vertical line crosses in more than one place. We do not want points on top of each other. So another example of not a function, even if it's not continuous, if I have two dots that are right above one another, not a function. Okay? I don't want any, because that means they have the same x. So that would not be a function. The simplest one that's not a function is if you just have a vertical line, not a function. So if it touches in more than one place, sometimes I use my pencil test. I hold my pencil up like a vertical line and move across the page. So as I move across, I want to think, is it a function? Is it not a function? So if it's not a function, I'm going to show you where. What's parts making it not a function? This is not a function, and it's because of these 2 points right here. See how they're right directly above one another, so it's not a function. 15, as I move across, no points directly above one another. Yes, it is a function. There's no vertical line that goes through more than one of those points. 16, also, yes, it's a function. 17, oh, no, it's not a function. Lots of places, right? I could look at this place or this place, like lots of places. There are lots of points on top of each other. If I drew a vertical line, it's cutting through this guy twice, not just once. So that's a no, not a function. So circles, ellipses, which basically means ovals, they are also not functions. So not a function. The V, as long as the V is opening up or down, is yes a function. In number 20, this is no, because the line is a straight vertical line, straight up and down, so there's lots of points on top of each other. 21, we can have curves. If I moved across, there are no points directly above one another. That is a function. So homework 1 is something you're going to do. Some of this comes from the other video and the notes about domain, range for both discrete functions like these first questions, and then domain and range also for continuous functions like 5, 6, 7, 8, which I'm talking about those on day 2. So that's near the end of that video. So if you miss Tuesday's class, it'll be near the end of that first video that I posted, and then this video to determine if something's a function. And then you have, like, are these functions or not, which is what I've just talked about in this video. The other thing that you're going to do is on IXL, and I'll show you what those look like. So we're going to be doing some IXL lessons where we determine if something is a function or not. Yesterday's IXL lessons were just about domain and range, or at least this term that broke out to be yesterday. We split up this lesson. Sometimes it would be the same. Let's hold on a second here. It looks as though my Doceri is taking a break here. Oh, here we go. So Q4, this is just yes or no questions. Please pay attention so that it does not get frustrating. So is this a function? I see 2 things coming out of 11, so the answer is no. You're welcome. If I have a graph, I don't want any points right above one another. So this is a yes. Nothing is above one another. I could also have written down all my x and y, all my x's, like write down my domain. And then here's a vertical line test. Again, it's yes and no. So this is very much like what you saw in your notes. That's Q5. And then eventually we'll also be doing Q6. You may or may not start that today. This is, well, probably on the same day. So this says plot the point with an x value of 5. So x value of 5, follow it to the line, and then the y value of that point is 6. Now, besides being called domain and range, you need to know that the x and the y could also be called input and output. So let's see. Some of these questions asked that way. Here, when x is 2, and now I don't have, still need to find it, but I don't have to plot it anymore. So after a while, you'll just be finding the point and putting that in. Okay, I hope that this is helpful and that I will see you back in class soon. Thanks.